Hello all. In this lecture we'll see about hashing techniques and mainly we'll see about internal hashing. So this is the outline of this lecture. We'll see what is hashing, internal hashing, then hashing functions and collision resolution. So hashing is a file organization technique. So this provides a very fast access to records under certain search conditions, and these kind of files are known as hash files. Okay, and here the search condition must be an equality condition on a particular field. We call that field as hash field, and most of the cases this hash field will be the key field, and we call it as hash key. Okay, hash key. So the basic idea behind hashing is to provide a function h. So we have a function h and we call it as hash function or randomizing function, which is applied to the hash field value of a record and yields the address of the disk block in which the record is stored. So we have a h function, we have a function h. What we do is we simply apply that hash field value to that function and you will get some value, and that value will be the address of the disk block. Okay, so for most records we need only a single block access to retrieve the thread record. So that's the advantage of this hashing. We need only a single block access, but in certain cases we may require, we'll see those cases later. So internal hashing. So in internal hashing is used for internal search structure for a program. For example, if we have a group of records that is stored inside a file, and if it is not ordered, then if we want to find a particular record, so we need to do some mechanism. So we have some hash function and we will apply that value and find out where that record is located inside a particular file itself. So that is why it is known as internal hashing. So internal hashing means internal search structure. So internal search structure within a program whenever a group of records is accessed exclusively by using the value of one field. So that is why it is known as internal hashing. So this is not related to disk block. So this is related to a particular file itself. Inside that file we have many records. So if we want to find a particular record inside that file, where that record is located, so we will apply that hash function and we will get some value, and that value will point to the particular record. So what we do is we use a hash table through the use of array records. We use an array of records. We have an hash table. So this is a hash table. So this is how it will be looking like. So what we have written is here internal structure, and this is implemented using a hash table and using array of records. So what we have here is something like this. So we have array of records like this. So 0, 1, 2, 3. So there are m number of records. So this array ranges from 0 to m minus 1. So we have m slots or m addresses. We have m slots or m addresses because 0 to m minus 1 is there. So there are m slots or m addresses or m indexes are there. So we will have a hash function. So array index ranges from 0 to m minus 1. So we choose a hash function that transforms the hash field value into an integer between 0 to m minus 1. So we will have a hash function. So commonly used hash function is k-mod-m. K-mod-m. So what we have to do is k will be replaced by the particular value or the key field value. So for example, if it is your register number, for example, if it is your register number or roll number that is used as k value, then roll number, if it is 25 and m is 10, let there are m arrays, or m is 100, let it m be 100, and k is 25, that is roll number is the k hash key value. Then 25 mod m means you will get 25 mod 100, it is 25. So there will be a 25th record. So the 25th record you will be storing the details of that student. Okay, if k equal to 121, so 121 mod 10, it is 21. Sorry, 121 mod 100, it is 21. So it will be stored in 21st record, okay, or 21st place. So this is the way we perform hashing. So we will have a hash function. A hash function, the commonly used hash function is k mod m. Okay, what we do is k is the hash key value and m is the number of array indexes. So we have a table like this. So what we do is we have this hash function and we have this hash field value k. It will be transformed into an integer from 0 to m minus 1. 0 to m minus 1 means this is some of address location. Okay. So we will simply apply this function and we will get a value from 0 to m minus 1. If we get 2, it will be stored here. If it is 3, the details will be stored here like that. We can have other hashing functions also. So one of the other hashing function is folding. We can use folding. So folding involves how we do folding is we will apply an arithmetic function such as addition or logical functions such as exclusive or to different portions of the hash field. So we have a hash field and we take that hash field itself. For example, the hash field is your Aadhaar number. Aadhaar number, it is a 12 digit number. 12 digit number is your Aadhaar number. Now what we do is we take that 12 digit number and we perform some arithmetic function on that 12 number. So example for folding, I'll show an example. So for example, if we have an address space from 0 to 999, there are 100,000 keys can be stored there. So 1,000 records can be stored in this address space. We have a 6-digit key like this, 23569. Let it be a unique number, maybe a university register number, 23569. So what we have to do is folding. We have to take this key and we have to perform some arithmetic operation on this key. So what the arithmetic operation we perform here is 235 plus 964. See, we simply uh, reverse these last three digits. Okay, 235 plus 964 mod 1000 because we have 1000 locations. So mod 1000 we will get some value 199. So this will be the hash key value. Okay, and this is the hash function. So folding is we will not take the hash field as such or the hash key as such. What we do is we will do some arithmetic functions such as addition, or we can perform logical functions like exclusive or on these operations. So what we have done is we have taken the first three digits as such and the last three digits is reversed and we'll sum up those two things. So this is known as folding. So this is another kind of hashing function. Then another way to choose a hash function is picking some digits of the hash field value. For example, we take the third, fifth, and eighth digits. For if we are taking the hash field value as social security number, so this is the hash social security number. So we will take only the third, fifth, and eighth digits. So here the third is 1 and fifth is 7 and eighth digit is 2. So we will get the answer as 172. So this is the hash key value or the hash function value. So the details of this person will be stored at 172th record, 172nd record. Okay. So this is another method. This is another hashing function. We will simply pick some digits of the hash field value. So it can be like this. So we'll write it in the program how to pick up those field values. Okay. Then in all these cases collision can occur. So there's a possibility of collision. So what is this collision? So collision means hashing functions do not guarantee that distinct values will hash to distinct addresses. For example, in the previous example, we have seen that social security number, we are taking the first, fifth and third, fifth and eighth digits. So we will get a hash value as 172. Okay. So if we have another social security number, this is another person's social security number. So if we are taking the same digits, so if we are taking the same digits, we are taking the third, fifth and eighth, we will get the same 172. So 172 and 172. So both have the same hash value. Both have the same hash value. So that is what is written here. Hashing functions do not guarantee that distinct values will hash to distinct addresses. So 172 and 172, both records cannot be placed at the same location. So this is known as collision. So this is known as collision. Okay. So this is known as collision because they do not guarantee, hashing functions do not guarantee that distinct values will hash to distinct addresses. They may be hashing to the same address location. So we have to do something. Some method should be there to do this collision resolution. Collision resolution mechanism should be there. So hash field value for insert record hashes to record already containing a different record. So that is the problem. So we have already inserted an employee details in this 172nd location. If another employee performs hashing function and gets the value 172, and if we try to insert this record there itself, then the previous one will be deleted. So that should not be done. So that is a problem with this collision. So hash field value for insert record inserted record hashes to address already containing a different record. So we have to do this collision resolution should be done. Whenever collision occurs, we have to do this collision resolution. So it is the process of finding another position. If both are 172, then the second one should be positioned at some other location. So how to do that? So we have different methods. One is open addressing, second is chaining, and third one is multiple hashing. So these are the three methods for collision resolution. We will see each one separately. So in open addressing, so what we do in open addressing is we will proceed from the occupied position. So now 172 is occupied. So what we do is we will proceed from the occupied position specified by the hash address. The program checks the subsequent positions in order until an unused empty position is found. So that is what we do. So if both are hashing to the, if the second record is hashing to the same value like 172, it will not be stored there. It will traverse, it will check whether any subsequent position is vacant or unused space is there. If some unused space is there, we will store the second 172 there. Okay, so this is known as open addressing. Then second method is chaining. So chaining, what we do is various overflow locations are kept separately. We will keep separate overflow locations. And additionally, a pointer field is added to each record location. So collision is resolved by placing the new record in an unused overflow location. So what we do is in chaining, what we do is if 172 and 172 we get for two different records. For the second record, what we do is we will place it in the overflow location. There will be some overflow locations. So and set the pointer of the occupied hash address location to the address of that overflow location. I'll show an example. So this is an example. This is the original address space. 0 to M spaces are there. We have already seen 0 to M spaces will be there. So these are the original spaces, and we call this address spaces. So when hash function is applied, it will be mapped to 0 to M minus 1. Some values will be mapped. And if some collision occurs, if 1 we get 2, second one also as 1, when you apply this hash function as 1, what we do is we have an overflow pointer here. Overflow pointers are there. In each record, there will be an overflow pointer. So if another record has a collision with this one, we will store the address of the overflow record here. So here M is the overflow record. So these are the overflow spaces. So M is in the overflow space. So if another record hashes to the same thing, then it will store this address and we can see that record here. That is, if 172 and 172 are both hashing to the same record here, first 172 will be stored. When the second 172 comes, it will go to this overflow pointer and it will store there. Here also, in fourth also, there is another overflow. That means another record is also hashing here. So what happens is it will go to the M plus 2 record. And if you check M plus 2 again, there is another overflow here. So it will go to the M plus 4. Like that, there will be some overflow space and address space separately. Whenever an overflow occurs, it will go to the overflow space. It will take some overflow space, and this overflow pointer will be updated. So that is what we have written here. So a pointer field is added to each record location. Collision is resolved by placing the new record in an unused overflow location, and after placing that in the unused overflow location, we will set the pointer of the occupied hash address location to the address of that overflow location. So that is why we will update the address here. So here -1 means null pointer. It is not pointing to anything. Only one record is hashed here. Okay. Here it means there is another one more record that is hashed. It is stored in M, and if you see M, another one more record is hashed here, so that is stored in M plus 5. Like that we can have chain of records. That is why it is known as chaining. Then the third method for collision resolution is multiple hashing. Multiple hashing. So when a collision occurs, what we do is program applies a second hash function if the first results in a collision. And if another collision results in the second hash function, the program uses open addressing, the first method for collision resolution. We use the open addressing, or we can apply a third hash function and then use open addressing if necessary. So this is known as multiple hashing. So when collision occurs, what we do is we will have a second type of hash function, and we will apply that second hash function. And if another collision results, either we can do this open addressing method. Open addressing means we will find the next vacant position and we will fill that, or we can apply a third hash function, and then after that we can use open addressing. So this is known as multiple hashing. There will be multiple hash functions. That is why it is known as multiple hashing technique. So these are the internal hashing techniques. So this is a series of hash functions are used in the same. So if we want to retrieve some information, so this is storing information, and if we want to retrieve information, we have to apply the same series of hash functions, should be applied in the same order for retrieval. Okay. So this is a reference. Thank you.